So hello everyone, my name is Diego Achaval. I work for Nokia and we've been testing all of this UPA thing, you know, along with Cisco and Juniper, of course, for the last few months. So first of all, what is UPA? So let's start first with, well, SRv6 takes advantage of summarization or road summarization that has been there forever for IPv6, right? So SRv6, luckily for all of us, takes advantage of that. So, but there is a drawback always associated to summarization, which is the loss of prefix reachability, right? So that poses a problem in an SRv6 context, right? So for that, we have UPA. So what we do with UPA is basically advertise unreachability of specific prefixes and let BGP applications leverage those advertisements in order to enable or fire BGP peak, right? So this is the first time that we have tested this at the EANTC, right, Jose? And we've tested this before. It wasn't the first time. It's the first time at the EANTC. We've tested this before, but yeah. So let's jump into the demo. So this is the scenario basically where we have tested first with Cisco and Nokia devices as the AVR or ASVR in this case. And we have also tested with Cisco, Nokia, and H3C devices as ingress PE. So the ingress PE in this case is the one that is going to be taking advantage of the UPA route and then firing BGP peak, right? In order to reduce or in order to have a better convergence in the post of node failure, okay? So as you can see, so the steady state scenario is basically where you can see traffic in ingress on the Nokia PE node on the left-hand side, which is sent either to the Juniper node or the Cisco node on the far right side. In this case, the traffic is being sent to the Cisco device, right? So what will happen here is that the ingress device is going to install a single route with a couple of next hops or a backup path. So we will have a primary path or a primary next hop and a secondary path or secondary next hop. So then peak, once we detect the loss of reachability to the next hop of those VPN IPv4 routes, we are going to switch over from the primary path onto the secondary path, okay? So, and this is what you can see. So just a few things before we jump into the demo. So you will be seeing amazing packet loss duration in this case. So it's going to be closer to 0. So don't be surprised by that. I will explain why you will be seeing that. And what we see in this case is the loss of reachability. The first step, we lose reachability to Juniper MX204 node that you see on the right side of the topology. And then once we lose reachability to that node, the AVR is going to detect the loss of reachability to that node and generate the UPA into the level 2 topology in the network. So then the ingress PE will receive that UPA route and fire BGP peak, okay? So let's go to the demo, right? So let me just put this here. It's the first time doing this, so I hope you can hear me well there. Okay, perfect. So let me just go back. So we are here. This is the ingress PE, right? So in the ingress PE, as you can see, we have a road where we have 2 next hops, right? So, and the next hops, or basically we have a road that is resolving to a couple of SRv6 tunnels, right? So you see SRv6 tunnel 302, this is the one going to the Cisco device, and 344, sorry, to the Juniper node, sorry, and 344 is the one going to the Cisco node, okay? So let me just show you quickly in the topology here. We have device 302 and device 344, okay? So, and as you can see in this road, we have the primary path and the backup path, okay? So let me show you that without the extensive command. So you can see here in this case that we have a backup path and we have the primary path being programmed in the forwarding path at this point in time, okay? So with the extensive command, we can see both. Let me show you the traffic generation here. So we have, as you can see here, we have a IX network configured to generate traffic from ingress PE to egress PE, right? And in this case, what we are going to be doing in IX network is basically tracking flows that are flowing basically between PE nodes, right? Yeah.
So, hi guys, as Diego was mentioning, we are using our solution IX network from Keysight to generate traffic. So, I'm generating traffic from part 1 and part 2, and we are going to track this by VLANs to track the egress traffic and see that we are, thank you, and see that we are effectively receiving it on Juniper. Traffic is going on, we can see that we have no loss, and we are receiving it on Juniper. So, yeah.
Thank you.
So leaving you with Diego.
Thank you, Malake. So as we were saying before, so quick refresher. So we have traffic flowing from ingress PE all the way to the Juniper PE, okay? And now Christophe here from Juniper is going to be simulating a node failure on the egress Juniper node, and we will see on the Ixia side and also on the ingress PE side how the forwarding state is changed and how the traffic flow starts flowing from ingress PE to Juniper PE, and it changes to the Cisco PE, okay? So let's just give me a moment. So yeah, let's do that, Christophe. So Christophe is going to simulate the failure. So we see the UPA there. We see the UPA, right? So this is the unreachable prefix announcement that we received from the Cisco ABI in this case. So when we receive this on the ingress PE, we see automatically that the routing table is changed. So before we had the seed that we were using was 302, and now we are using seed 344. So that means that traffic is flowing now through the Cisco device, right? And if we go back to IX network, so we can see now that traffic is flowing, instead of flowing to 302, is flowing to 344. And as you can see here, we have almost 0 packet loss, which is fishy, right? But in this case, the reason why we have that packet loss, which is kind of unrealistic, right, is because the node failure that we are introducing here is actually not a node failure. We are just shutting down a loopback interface, and that signals loss of reachability to the AVR in order for the AVR to be able to generate the UPA. Of course, in a more realistic scenario, you will test this by shutting down a node completely, and you will have different mechanisms to detect the loss of reachability, like, for example, BFD between the failing node and all the adjacent nodes, and also the AVRs, okay? So I think that's it for the demo, right? So thank you. Okay, thank you very much for your time. I hope if you have any questions, just feel free to reach us here. All right, thank you.
Right. All of the vendor experts are here, so please don't be shy. Thanks to all the vendors who participated in this demo and also shuttled around, taking turns in presentation. We're really fortunate at EANTC to see this multi-vendor collaboration going very well.